All right, chapter 26, day 4. What we're going to do today is another chi-squared test, but it's very similar to the last one that we did. This chi-squared test is called the chi-squared test for association, or some people might call it a chi-squared test for independence. You can use either word here. So in this case, it uses one population on two variables. All right? So instead of homogeneity, which uses multiple populations on one variable, this is one population, two variables. All right. And so when you're given the scenario, you have to ask yourself, what's my population? What are my variables? And that will help you distinguish between the association or independence test or the homogeneity test. So null hypothesis is that HO, the initial hypothesis, is that there's no association between the variables, that they are independent. Okay? HO, no association between the variables. The alternative, what you're trying to show evidence for, is that there is an association between the variables. Somehow that they're not independent, that they are associated. All right? Well, here's the good news. The entire test, conditions, conclusion, everything is the same as homogeneity. The expected counts, all of that stuff is the same. When you check your conditions, it's the same conditions check, except you would say, okay, to do a chi-squared test for independence or association. Usually you'll hear the word independence or association within the question that they're asking. That usually will help tip it off a little bit. For example, here's one that we could look at. For example, is there an association between eye color and the need for glasses? You know, is there somehow any association between the color of someone's eyes and whether or not they have corrective lenses? So right now you can hear the word association in the question, so it helps you decide which one to pick. But if we think about this, I took a sample of people. I have one population. All right, here they are. On two variables, eye color and whether or not they need glasses. So this is a chi-squared test for association. Some of you might argue and say, well, you have two populations, those with glasses and those without, on one variable, which is what eye color are they. So it depends on how you look at it. I think in this sense we're going to look for an association. Is there somehow a link between eye color and whether or not they have glasses? You would take this data, put it into your matrix, and run the same exact test that we just run. So what I want you to do is to use this data, go ahead, write your HO and your HA, check your conditions and run a test, and when you come into class, we'll see what the results are. And that's it. It's a very quick show because the test is almost identical to what we just got done doing.